Hello and welcome to your first video of geometry. I'm going to be recording this video, and these notes go along with the Geometry Notes 1.1 Basics of Geometry Notes. I have posted them in Google Classroom blank, so you can print it out and fill them in if you would like. Or I have posted the filled in copy as well, so you can look at the filled in copy after you watch the video. But every time, what I would recommend is not just looking at the notes. I would highly recommend that you watch and listen to the video as well. When I make videos, I try to make them manageable, and it's not going to be anything terribly long, but it will pay off for you if you listen to the video and watch the video, because there will be things in the video that aren't necessarily on the notes, but are also important concepts that may come and show back up. Okay? So today we're going to talk about points, lines, and planes. So a point has no dimension, and a dot represents a point. That's pretty straightforward, probably something that you've seen or heard before, okay? A line, however, has one dimension. So it has a line with two arrowheads, but extends without ends. So like these arrows at the ends of this line, that shows that the line continues out in both directions infinitely, so it has no end, but you can't draw that on a piece of paper, so how we signify that is with the line. Now, the other thing that's really important is we can name this, and you can write out the word line L. You can call it the word line AB. You can write it as AB with a line with two arrowheads over it, but it is very, very, very important that when you're writing it like this with no word line there, you have to show that it's a line by putting these two arrowheads on the end. Okay, or you can write line BA, or with the line with two arrowheads over the top of BA. Okay, so it's like this, and again, the part that's really important is this arrow and this arrow. The arrows, the order doesn't matter when it's a line because it goes both directions, or when there's a lowercase letter like that, you can name it line L. A plane has two dimensions, so it's like what you would think of as a piece of paper. I always will hold up a piece of paper. That's a plane, okay? It looks like a floor or wall, but it also extends without end. So it's like, even though these edges are shown, we assume that this plane just continues out in all four directions, okay? We just have to show it somehow, and so we draw it like that. So you can see that it almost looks like a flat piece of paper or something that is flat. So through any 3 points not in the same line, there is exactly one plane. So A, B, and C, you can't draw a line through them, so that is how we would name it. We would name it plane ABC. Or sometimes we label the plane, the picture of the plane M, so that doesn't have a point next to it or a line. It is actually the name of the plane, so we can name it plane M. But you have to, when you're naming a plane with 3 points, it has to be 3 points that are not in the same line, okay? They cannot be in the same line to name the plane, okay? So there's different parts of a line that we can kind of divide up. So the first thing is a line segment. So line segment is just a piece of a line. It has 2 endpoints, okay? And so when we drew a line, so like the line AB is like this with the 2 arrowheads on the end. This is segment AB because there are no arrows, and it can be segment BA as well because the order doesn't matter because it's endpoint to endpoint. Okay, but a line segment has 2 endpoints. Okay, and then we also talk about rays. So rays, the order matters. Okay, I'm going to say that. Order matters on these, okay, because if the endpoint is at A, then A has to be the part with the endpoint there. So you see there's no arrowhead right there. So AB, this is ray AB, okay? And then this one here is ray BA because the endpoint is at B. So you need to see that. The part with no arrowhead is with B, okay? So they're different rays. So even though they both have A and B on them, they're different because B is the endpoint of this ray BA, and ray AB has endpoint A. Okay? Opposite rays are 2 rays that have the same endpoint and extend in opposite directions. So on this, the example would be that CA, so ray CA and ray CB are opposite rays because CA goes this direction and CB goes this direction, and they have the same endpoint, so they both start at point C, and that's the endpoint, but the direction they go is opposite. Okay? All right, so collinear points. Collinear points are points that lie on the same line. So again, when we were talking about naming a plane, I said the points that you name the plane with, the 3 points, you name 3 points to name a plane, they cannot be collinear. They cannot lie on the same line. So on this first diagram here, A, C, and B, those are all collinear points, okay? On here, we have S, P, and T that are collinear, okay? But you can see that V is not because it's not on that same line, okay? Q and P are collinear points, and any 2 points are collinear, okay? So you can draw a line through any 2 points. So any 2 points you pick are going to be collinear. It's when you throw that third point in, or the line in, to sit, and that's when you're going to have to really question, can there be a line that is drawn through all those things? Are they really collinear? So on this diagram here, we're looking here, we have line AB, which is this line here, and point C. So yes, these are collinear because they all lie on the same line. B and F, however, these it's just 2 points, and so we actually don't even need to look at the diagram because this is point B and point F, and these 2 points are always going to be collinear. You don't actually have to know what they look like. If you are given 2 points, they are collinear. There is no way for 2 points to be non-collinear. It's when you throw in a line or a third point. Okay, so now we have line EB, which is this guy here, and point A. Does point A lie on line EB? The answer here is no, so they are not collinear. Okay, this last piece here is not, or I'm sorry, we're not quite there yet. I'm jumping ahead. So coplanar points are points that are on the same plane. Okay, so the way that any 2 points are collinear, any 3 points are going to be coplanar. It's when you throw a 4th point in that you really have to question it. So like A, B, and C, those are coplanar. And when I'm thinking coplanar, how I visualize it, and it's hard to like show on here without being in person, but I would visualize, could I slide a piece of paper through all 3 of those points? And yes, if you look at this green shaded piece down here, you could think of that as a piece of paper, and it can go through A, B, and C. Okay? Also here, E, B, and C are coplanar because I could slide that piece of paper diagonally through that cube and get that E, B, and C are all that paper could go through all 3 of those points. Okay, so they are coplanar. So let's look at this diagram and see if we can answer some coplanar questions. Okay, so A, B, E, and C, are they all coplanar? Well, I can see from this diagram on plane Q, this whole big plane here that's on this diagram, A, B, C, and E are all on that plane. So yes, they are coplanar. Okay. A, B, and F, any 3 points, so even though they're not all on this plane that's in the diagram, any 3 points, so these are 3 points, yes, they are coplanar. Any 3 points are coplanar. Okay. Line EB, okay, so that line there, and point A, oh, also coplanar because they all lie on Q. So an example of something that wouldn't be coplanar, so non-coplanar, non-coplanar means not on the same plane. So just so you have an example of a non-coplanar set of points, A, B, E, and F. Those would not be coplanar because A, B, and E are all on the same plane, but point F is not. Or A, B, and F are all on the same plane, but then point E is not, okay? Because you couldn't slide one piece of paper through, oh, and that's actually incorrect. How about A, B, oh no, that's right, sorry. A, B, E, and F would not be coplanar because you couldn't slide a piece of paper through them. And then something that's not collinear would be 3 points that do not make a line. Okay. All right, this last piece is not on your notes, but you do need to know this. This is very, very, very important information. I would add this to the end of my notes if I were you. The intersection of two lines is a point. So two lines, the intersection of two lines is a point, and the intersection of two planes is a line. Okay, so when two planes, you could think about it as two pieces of paper, you know, and if you were to intertwine them there, they would create a line. Okay, and whenever two lines cross, that creates a point. Okay, so we talk about intersections, and that's where they cross. So again, super important information. The intersection of two lines is a point, and the intersection of two planes is a line. Okay, and just to encourage you to continue to watch these videos, every once in a while I'll throw a carrot in at the end or in the middle somewhere. And so what I would like, if you would like one extra credit point on your first assignment, is you to email me and tell me you watched the whole video, and also tell me what your favorite place to eat breakfast is. So do you have a favorite breakfast restaurant or a favorite breakfast that you cook or anything like that? But if you would like one extra credit point on your first assignment here in geometry, please email me. Tell me you watched the whole video, you learned about the intersections, and what is your favorite breakfast joint. Also, please email me or let me know if you have questions. Otherwise, we will meet again on Monday.